So welcome to my lecture series. So in previous video we discussed about what is superconductors and the properties of superconductors. So in this video we discussed the Meissner effect. So Meissner effect and isotope effect. So when the superconducting material is placed on a uniform weak magnetic field and is cooled below the transition temperature, so the magnetic flux lines inside the material are completely expelled from the material. So this effect is called Meissner effect. So from Meissner effect, so one can conclude that the superconductor is a perfect diamagnetic material. So this effect is reversible. So that is when the temperature of a superconductor kept in a uniform magnetic field is rises from 0 Kelvin to its transition temperature. The magnetic flux lines, the superconducting start penetrating into the material, and the superconducting state is destroyed into the normal state. So under this normal state of magnetic induction is given by V equal to mu naught I plus H. So here H is the applied magnetic field strength and I is the intensity of magnetization produced inside the material. So but in the superconducting state by Meissner effect, so B equal to mu naught I plus H equal to 0. So that means I equal to minus H. So 1 by H equal to magnetic susceptibility. So thus the superconductors has a negative magnetic susceptibilities and hence it is a diamagnetic material. So the isotope effect, the found that the transition temperatures are inversely proportional to the square roots of the atomic weights of the isotopes of a single superconductor. So thus M directly proportional constant. So where alpha is that constant and it's approximately equal to the 0.5. For example, the atomic weights, the isotopes, mercury range from 199.5 to 203.4 atomic mass units. So therefore, their transition temperatures are ranged from 4.185 Kelvin to 4.146 Kelvin respectively. So next one, types of superconductors. So based on the critical magnetic field, there are two types of superconductors: type 1 superconductors, type 2 superconductors. So type 1 superconductor is the one which exhibits the complete Meissner effect or perfect diamagnetism. So that is above the critical field Hc. So the specimen is a normal conductor. So below the critical field, the specimen includes the magnetic lines of force inside the specimen, or it will become a diamagnetic material. So these are also called soft superconductors. So the values of Hc are always too low for these materials. Examples: aluminum, zinc, gallium. The value of magnetic field H increases and the magnetism of superconductors also increases. Above the critical magnetic field, it turns into the normal state. So this reversible process, the value of applied field decreases. Material expels the magnetic field lines and retains to the superconducting state. So type 1 superconductor also allows the magnetic field lines to penetrate the lower value. So Hc therefore they are also known as the soft superconductor. So mostly pure elements like aluminum 0.0105 Tesla and zinc 0.0054. So are example of soft superconductors. And next one, type 2 superconductors. Type 2 superconductor magnetic flux starts to the penetrate the specimen at the field Hc1, so which is lower than the critical field Hc. So the specimen is in the mixed state between Hc1 and Hc2, and its gas superconducting electrical properties up to Hc2. Above Hc2, the specimen is a normal conductor. So the type 2 superconductors are called hot superconductors, which have the large amount of magnetic hysteresis induced by the mechanical treatment. So solenoids wound with wire of a hot superconductor can produce field over 100 kilotesla. So heavy cold work and recovery of annealed materials having dislocations, density and fine grains are used making a type 2 superconductor. For examples of superconductor, zirconium, niobium 60%, niobium 40%, titanium alloy. So thank you. We discuss in next video.